Picture our planet, the Earth as we know it today. A blue and green oasis in the vast cosmic desert teeming with life, thanks in large part to the unique composition of its atmosphere. It's a delicate cocktail primarily composed of nitrogen, at a whopping 78%, and oxygen, the breath of life itself, making up around 21%. The remaining 1%? A mix of argon, carbon dioxide, and trace amounts of other gases. This blend isn't just a random assortment, it's a finely tuned balance, maintaining temperatures that allow water to exist in all three states: solid, liquid, and gas. It also provides a protective shield, deflecting harmful solar radiation and meteoroids. All these elements come together to create the right conditions for life as we know it, an environment that nurtures and sustains us. But what if this delicate balance was to change dramatically? Now, consider our planetary neighbor Venus, a world quite unlike ours. It might be the same size as Earth, but that's where the similarities end. Venus is a place of extremes. It's a hot, hellish inferno cloaked in a thick yellowish haze. The air is suffocating, the ground is melting, and the environment is anything but welcoming. The atmosphere of Venus is primarily composed of carbon dioxide, a dense and heavy gas that blankets the planet. This thick cover traps the sun's heat, creating an extreme greenhouse effect. Consequently, the surface temperatures on Venus are scorching, exceeding 870 degrees Fahrenheit, or 460 degrees Celsius. To put that in perspective, it's hotter than the surface of Mercury, the planet closest to the sun. Venus doesn't just have heat to contend with, but also a cocktail of chemicals that would have any living creature gasping for breath. Among these is sulfuric acid, which forms dense clouds that swirl around the planet. These clouds are so thick that they completely obscure the surface from view. And if you were to breathe in this toxic air, well, let's just say it wouldn't be a pleasant experience. And then there's the pressure. The atmospheric pressure on Venus is crushingly high, around 92 times that of Earth. It's like being a kilometer under the ocean, with the weight of the water pressing down on you from all sides. Yet amidst all these hostile conditions, Venus has no breathable oxygen. The air is mostly carbon dioxide, with traces of nitrogen and sulfur dioxide. It's a far cry from the life-supporting mix of oxygen, nitrogen, and carbon dioxide that we have on Earth. Venus, a planet not too dissimilar in size to Earth, is a deadly, inhospitable world. A stark reminder of how different two planets can be, despite their similarities in size and proximity to the Sun. So what would happen if Earth's atmosphere transformed into one resembling Venus? This isn't the plot of a science fiction movie, but a hypothetical scenario that propels us into a fascinating, albeit terrifying journey of exploration. Firstly, let's consider the potential causes for such a drastic transformation. One likely culprit is the runaway greenhouse effect. Currently, our planet's atmosphere is delicately balanced to trap just the right amount of heat from the sun, maintaining a temperature hospitable for life. However, if too much carbon dioxide is released into the atmosphere, it could trap an excessive amount of heat, skyrocketing Earth's temperatures. The immediate effects would be catastrophic. Our blue skies would turn into a thick, yellowish haze, as the formerly nitrogen and oxygen-rich atmosphere becomes dominated by carbon dioxide. The air would become suffocating, and the ground beneath our feet would start to melt. The average surface temperature would soar, exceeding 460 degrees Celsius. That's hotter than the surface of Mercury, the closest planet to the sun. The oceans, which cover over 70% of our planet, would begin to boil and evaporate into the atmosphere, further intensifying the greenhouse effect. As the water vapor rises, it would break down in the upper atmosphere, releasing hydrogen that escapes into space and oxygen that reacts with surface rocks. Life as we know it would be impossible. Most living organisms, from the smallest bacteria to the largest mammals, are adapted to survive within a specific range of temperatures and atmospheric conditions. The extreme heat and high concentration of carbon dioxide would be lethal for almost all forms of life. Even extremophiles, organisms that thrive in extreme environments, would struggle to adapt to these harsh conditions. Let's not forget about the sulfuric acid clouds found in Venus's atmosphere. If such clouds formed on Earth, it would mean acid rain corroding everything it touches. Buildings, bridges, and monuments would crumble, and the protective ozone layer would be destroyed, exposing the scorched Earth to lethal levels of solar radiation. Over the long term, Earth would become a barren, inhospitable wasteland, shrouded in a thick, toxic atmosphere. Its surface, once teeming with life, would be replaced by a molten landscape of rock and lava, reminiscent of Venus's current state. The transformation of Earth into a Venus-like planet would be the ultimate testament to the planet's resilience and adaptability, albeit a horrifying one. It's a reminder of the delicate balance that allows life to flourish on our planet, and the catastrophic consequences when this balance is disrupted. In this new world, survival as we know it would be impossible. But this terrifying scenario underscores the importance of understanding and protecting our planet's atmosphere. It's not just a layer of gases, it's a life-supporting system, a shield protecting us from the harshness of space, and a testament to the incredible complexity and fragility of life on Earth. As Earth transforms into a Venus-like world, the consequences would be dire. The first casualty of this dramatic transformation would be our polar ice caps. The extreme heat, with temperatures soaring well above 460 degrees Celsius, would make short work of the ice at the poles. The resultant meltwater would surge into the oceans, causing sea levels to rise dramatically. Coastal cities would be the first to succumb, swallowed by the encroaching tide. This wouldn't be a slow, gradual process, but rather an accelerated submersion, a relentless wave that would spare no shoreline. From the towering skyscrapers of New York to the vibrant markets of Mumbai, all would be claimed by the sea. But the flooding is just the opening act in this tragic play. The atmosphere, thick with carbon dioxide and clouds of sulfuric acid, would pose an even graver threat. Breathing air, a simple act we take for granted, would turn into a deadly gamble. Without protective gear such as gas masks, the corrosive air would wreak havoc on our respiratory system, leading to widespread suffocation. And then, there's the matter of life itself. The extreme conditions wouldn't just be inhospitable to humans, but to all known forms of life. The scorching temperatures, the acidic air, the lack of sunlight penetrating the dense atmosphere, all these factors would make survival virtually impossible. Plants, unable to photosynthesize, would wither and die, breaking the first link in the food chain. Animals deprived of food and clean air would follow suit. In this Venusian world, Earth's vibrant ecosystems would collapse. The lush forests teeming with life would be replaced by barren wastelands. The vibrant coral reefs, home to a myriad of sea creatures, would crumble under the acidic seawater. The chirping of birds, the rustling of leaves, the roar of the ocean, all these familiar sounds would be replaced by eerie silence. Our beautiful blue planet would become a scorching, uninhabitable hellscape. A stark reminder of the delicate balance that sustains life as we know it, and the catastrophic consequences if that balance is ever upset. Our exploration into this grim scenario serves to highlight one crucial fact. The atmosphere that swaddles our planet Earth, while often taken for granted, is a precious, life-sustaining asset. It's a complex, delicate system that has evolved over billions of years to support the diverse array of life we see today. Our atmosphere performs a myriad of vital roles. It protects us from harmful solar radiation, keeps our planet warm through the greenhouse effect, and provides us with the air we breathe. It's a delicate balance, with each component playing a part. Oxygen allows for life, carbon dioxide promotes plant growth, and nitrogen provides a stable environment. Yet this balance is at risk. Human activities such as burning fossil fuels, deforestation, and industrial processes are causing a rapid increase in greenhouse gases like carbon dioxide and methane. This is leading to global warming, a rise in Earth's average temperature, which is causing a cascade of negative effects, from melting ice caps to devastating wildfires and extreme weather events. The smoggy, stifling conditions of Venus serve as a stark reminder of the consequences of a runaway greenhouse effect. It's a glimpse into a future we must strive to avoid. Our atmosphere is not a given, it's a treasure that we must guard with vigilance and care. The preservation of our atmosphere calls for a global effort. It's a shared responsibility that transcends borders and generations. Each one of us can contribute, whether through reducing our carbon footprint, advocating for clean energy, or supporting policies aimed at environmental protection. The health of our atmosphere is, in essence, the health of our home. It's an indicator of the viability of life on Earth. Our actions, or lack thereof, will determine the future we leave for our children and their children. Let's remember, our atmosphere is not just a layer of gases surrounding our planet, it's the breath of life itself. The fate of our planet and all life on it is in our hands.